In this video, we're going to look a little bit into absolute value equations, section 3.5 in the textbook. Okay, so we started out with just a little question. When does the absolute value of x equal 7? Well, it kind of just makes sense. What is that really saying? That's really asking you which numbers, right, which x values have absolute values of 7. And if you recall, probably like the first definition of absolute value that you ever got is that absolute value was the distance of a number from 0. So in other words, what this is asking you, what this equation is asking here is which numbers, plural, right, because there's going to be more than one, are 7 units away from 0. Well, it just makes sense that if you go 7 units to the right, you're 7 units from 0, or if you go 7 units to the left, you're 7 units from 0, right? So bottom line is the numbers 7 and -7 are both 7 units away from 0. So in other words, the solutions to this absolute value equation would just be x equals 7 or x equals -7, right? And again, we had talked about this in a previous video on inequalities. Or means only one of the two must be true, right? Because if I wrote x equals 7 and x equals -7, that's kind of a contradiction, right? Because x can't be both 7 and -7 at the same time. So you actually use the word or to connect those solutions. So it's x equals 7 or x equals -7. And what I just did there, really, just taking the x out of the absolute value and setting it equal to 7 and -7, that's really the process for solving absolute value equations, right? So when you have absolute value equations, bottom line, what you do is, first you isolate, right? You isolate the absolute value expression, and you got to make sure that it's equal to a positive number or 0. If it's not, then you're going to run into a problem, which we'll talk about later. So once you isolate, you then set up two equations, right? You set up two equations, one where the absolute value expression is equal to the other side of the equation, right, which is either the positive number or 0, and one in which it's equal to the opposite of the other side of the equation, right? And then, of course, you have two equations, so you just solve both of them, and then you check your solutions, okay? So it's a pretty straightforward process. Now, the question might be, why did that first step in our process stipulate, right, require that the absolute value expression should equal a positive number? Well, bottom line is, remember our definition of absolute value. Our definition of absolute value is distance, right? Distance from 0. So really, the reason that the absolute value expression should equal a positive number is that distance cannot be negative. So bottom line there is what I have in this box, which says that if you end up with some expression, right, some absolute value expression equal to a negative number, then the equation would have no solution. Okay? And the reason is that if you think of absolute value as distance, it makes sense, because distance cannot be a negative number. So if you have an absolute value equal to a negative, there's going to be no solution. All right. So we have a couple quick examples here to go through, right? So just follow our steps, right? Step 1 said isolate the absolute value expression. So in the case of the first one, the absolute value expression would be this. So you would look at it and say, well, is it isolated? Well, not yet, almost. I have this +5 hanging out next to it. So I got to get rid of this +5 by subtracting 5. And now I have the absolute value of 1 minus 2z equals 5. And now it's isolated, so I would move on to step 2. And step 2 said set up two equations, right? So I'm going to set up two equations, one where this absolute value expression, which is 1 minus 2z, equals the other side of the equation, which is 5, and one where it equals the opposite of the other side of the equation, which is -5. Right? And then I would just solve those two equations individually, and it's going to be the same steps involved, right? I'm going to subtract 1 from both sides. So I have negative 2z equals 4, and then I would just divide by 2. I'm sorry, negative 2. And then I would end up with z equals negative 2. And in the other one, I'm going to do the same steps, right? I'm going to subtract 1. But the difference is, in this one, I started with a negative 5 on the right side. So when I subtract 1 from negative 5, I'm going to have negative 6. And then when I divide both sides by negative 2, I'm actually going to end up with a positive 3. So my solutions would be z equals negative 2 or z equals 3. Right? And it's probably useful to actually look at this on a graph real quick. Remember what we had said in an earlier video about solving equations graphically and numerically? The process is very simple and it never changes. Whenever you want to solve an equation graphically, just enter one side of the equation as y1 in the calculator and the other side of the equation as y2 in the calculator. So in this case, my left side of the equation is y1, so I'm going to write this as the absolute value of 1 minus 2x, right? Because there's no c variable, you just use x for all the variables. And then plus 5, so that's my left side of the equation, and my right side of the equation is just 10. And if I graph this in the standard window, it's not the best picture because of the fact that y2 is 10, so I might want to make my y, instead of going from negative 10 to 10, go from like 0 to 20. And it'll probably give me a little bit better picture. Yeah, that's a much nicer picture, right? And again, what are you looking for? You're looking for the points of intersection. And in this case, the points of intersection, right, if I do calc intersect y1, y2, guess, my intersection is at negative 2, so that was my first solution. And then if I do calc intersect again, y1, y2, and in this case my guess is over here, which is x equals 3, and that was my second solution. Okay? So I've just checked it on the calculator graphically. And I mean, how can you check it numerically? Just go to the table. And you're looking for where y1 and y2 are equal. So where are y1 and y2 equal? Well, they're equal right here when x equals 3. And if I scroll up, they're also equal here when x is negative 2. Okay, so my solutions would be negative 2 or 3. So that was my first example. Now my second example is going to be a little bit different, right? But I go through the same process, right? My process was isolate the absolute value expression. So in this case, here's my absolute value expression, absolute value of 3y minus 2. So how do I isolate this? I would isolate this by getting rid of the 6, by subtracting 6 from both sides. And now this is where you got to be a little careful, because I now have the absolute value of 3y minus 2 equals negative 2. And this is where you have to stop yourself and go back to what I had written on the first step of my process, right? See how it says, once I isolate the absolute value expression, it should be equal to a positive number or 0. In this case, I have an absolute value expression equal to a negative number. So remember what we said? We said right here, if you end up with something that looks like this, then the equation has no solution. And that's what I have, right? I have the absolute value of something equals a negative number. So I stop there and I say, all right, absolute value can never be negative because I think of it as a distance. So I just stop right here and I'm done. I just say, there's no solution to this absolute value equation. All right, because absolute value cannot equal a negative number. And again, I mean, you can check this on a calculator also, which is kind of the nice thing about the calculator. you'll be able to verify that there's no solution. Go back to my y1 and y2, right, and do the same thing I did for the last example, right? All I have to do here is make y1 equal to the left side. So this is the absolute value of 3y minus 2. Plus 6. That's my left side of the equation, so y1. And the right side of my equation is y2, that's 4. And now if this one, if I do standard window, it might be a better picture. Nah, it's still not that great of a picture. I could have left my same window, it would have looked better. Make y, again, go from 0 to 20. And you see, that V-looking graph, that was my absolute value graph, right, my y1. And the horizontal line is my y2, which is y equals 4. Those lines, those graphs, they never intersect. So since those graphs never intersect, the equation has no solution. Okay, so you can see it graphically also. So that's just the thing you got to keep in mind, because that's generally people, find these fairly easy. It's just that you got to remember, if you have the absolute value of some expression equal to a negative value, it can never happen. Therefore, there would be no solution to the equation.